All right, physics. Here comes the. Something is already. Can I erase that? Great. Um, gonna go through Regents question by question. I'm gonna go in numerical order. So if you've done this one, it's the June 2018, right here, June 2018 Regents. Second to last one that was given. Last one was obviously 2019. Then y'all are gonna take 2022, which hasn't been released yet. But I'll go through 2018. I'd recommend just like going through, doing the questions, right? Sitting down, doing the questions, and then if you want to cherry pick and just see, oh, I need to find like number 62, like just fast forward the video to number 62. It's here somewhere, I swear. All right. So, oh, the other thing that I have open is just the reference table. So if I need to look at something, I have it. But let's check out this test. All right. Let's start with the part ones or the part A or whatever you want to call it. Multiple choice. But we need to start here. Number one, what correctly pairs the vector with the unit? Weight is a vector, but it's not kilograms. Velocity in meters per second. Right, speed is not a vector. Acceleration is meters per second squared. So that one's choice 2. Okay. Number 2, 12 kilogram cart moving into speed of something. The speed is tripled, but the inertia... Please don't get the inertia question wrong, y'all. Inertia is unchanged, because inertia is just mass. So nothing happened to the mass. And because nothing happened... There we go. Because nothing happened to the mass, the inertia is unchanged. Right? Okay, taking off from aircraft carrier, jet starts from rest, accelerates to a final speed of 40 meters per second. Runway is 70 meters long. What is the acceleration? So I have initial, I have final, I have a distance, I need an acceleration. This is the timeless equation, which, for reference, is... here it is. Vf squared is Vi squared plus 2 times A times delta D, or just D in this case. So that means that I have... If I change color here, I think you'll be able to see me over here. Oh, won't let me write over there. That's so sad. So Vf, so 40 squared equals 0 squared plus 2 times A times 70. So 1600 is 140A, so it's a little over 10. It's going to be 11 meters per second. I'll go in order, just because that's what I said I was going to do. Check my math there. I'll use a calculator real quick and check my math there. Don't turn 40 times 40. Yeah, 11.4. So it rounds to 11. Okay. We have, next question, we have a 6 kilogram cart, 4 meters per second, accelerates at 0.5 for 3 seconds. I want to know the speed. So I have Vi is 4, and the acceleration is 0.5, at the time is 3. I do have a mass of 6, but I'm looking for final velocity, so that is just... I'll do it above again. Vf is Vi plus At, which means Vf is 4 plus half of 3. 4 plus half of 3 is 4 plus 1.5. That's 5.5. And the reason, remember, the velocity and acceleration are in the same direction, so it is going to speed up. If it was going east and the acceleration was west, you'd have to subtract because direction is important, but not in this case. Alright. Ooh. No math question. Soccer ball is kicked into the air, initial speed of 20 meters per second, returns to the ground, so you kick a ball. What angle to go the greatest horizontal distance? That's always 45 degrees. Horizontal distance is 45 degrees. Vertical distance is 90 degrees. You need to fight gravity. Alright, so let's see. Starting from rest, it goes 18 meters, 3 seconds. What's the acceleration? Alright, this one is just distance is VIT plus 1/2 AT squared. Initial velocity is 0, so this all goes away, which means I'm just looking at 1/2 times... Oh, I'm looking for acceleration. Huh. Acceleration times time is 3 seconds squared. That equals 18. So 18 times 2, 36 is 9a, which means that a has to be 4 meters per second squared. Is that math right? Goes 18 meters, that's the distance, times 2. Yeah, it's also 18 divided by 4.5. Okay. Ball rolls horizontally, leaves, hits the floor that much time. What is the acceleration after it leaves the tabletop? Well, after it leaves the tabletop, it's a projectile. 9.81 meters per second squared. We fire a projectile. What's going to give it the biggest time of flight? Mass doesn't affect time in the air. If I decrease the height, that's not great. If I increase the horizontal velocity, that doesn't do anything for time in the air. So it has to be choice 4. Has to be. So increasing the height is the only way to make something be in the air longer. Okay. We hit a golf ball with an average force. So I have a mass, I have a force, and I have a speed. What is the impulse? Well, normally impulse J equals F times T, but I don't have T. I can do that impulse is change in momentum, and momentum is mass times velocity. So 0.05 times 44 is going to be 2.2. That's choice 1. Alright, tennis player's racket applies an average force of 200 newtons to a tennis ball. What does the force on the racket by the ball? Well, if it's 200 newtons here, it's 200 newtons there. Equal and opposite reactions. Equal and opposite force. Alright. Number 11. Nice, easy, straightforward question. I want the force of friction. If we're going this way, friction points the other way, so that's choice D. Oh, here it is. What diagram represents the velocity and acceleration as it moves in a circle? Acceleration has to point towards the middle, has to be choice 1. Charged particle is an electric field where the electric field strength is this and the force is this. What's the charge? Okay, so electric field strength, electric force, and charge. That's an electricity question. It's right here. Electric field strength is force divided by charge. So that means that 2 times 10 to the third equals 3 times 10 to the negative third over Q. If you want to solve for Q, you got to multiply it over and then divide. So it's going to be 3 over 2 is 1.5 times 10 negative 6. Okay, 14 looks like a complicated question. Gravitational field strength. Don't get thrown off by this though. Gravitational field strength, we talked about this a little bit. That is the same as the acceleration due to gravity, which means it's this guy here. It's just Fg, force of gravity, divided by mass. That's the first answer. Bang. Alright, car engine supplies this much energy during 10 seconds. And what's the power? Well, power is work divided by time. So I just need to do that divided by 10, which is going to be 2 times 10 squared. It was 2 times 10 to the third, but I divided by 10, so now it's 2 times 10 squared. Attract or repel. Right, gravity only attracts. Get off my lawn. Oh, look! Gravity only attracts, so it has to be choice 3. Compared to the resistivity. Okay, watch your words here. Resistivity. Resistivity is something that is specific to a type of metal or a type of material. If they are both the same type of material, then their resistivity is the same. If it said resistance, that can change. Resistivity is going to stay the same. All right. Work per charge. Work per charge. That's work divided by charge. Work divided by charge. Work divided by charge. That is V, which is the potential difference. That's choice 4. Work per charge. Work divided by charge. Work over charge. All right, it's a definition question. All right, 2 meter length. All right, so let's see. 2 meter copper wire. Potential difference of this. Current is this. Same copper wire, same temperature. The voltage is doubled. So what should happen to the current? If you give it twice as much energy, if you give it twice as much voltage, they should move twice as fast. The current should be twice as big. That's what's going to happen. Right? That's what will happen there. And think about it, right? If you give it more juice, right, you provide more electrical energy per charge, which is voltage, then those charges should be able to move at a faster rate, which is what current is. Current is how many charges are going by. If there are charges with more energy, they're going to go by faster. What is the gravitational force of attraction between two this mass soccer balls when their distance is this far apart? Okay, gravitational force between two objects means the big gravity equation here. So G times M1 times M2 over R squared. This is kind of gross because it's three very small numbers. So 0.425, I'm going to do the math on a calculator real quick. I got 0.425 times 0.425 divided by 0.5 squared. And multiply that by 6.67, 10 to the negative 11. It's 4.82, 10 to the negative 11, which is choice 2. Alright, sound wave can travel through water, but not through a vacuum. A red light wave from a laser can travel through both water and a vacuum, and you've seen that. A group of soldiers marches along a road. Each soldier steps simultaneously, but when they cross a bridge, they don't. That's because resonance can happen. You can collapse a bridge that way. What characteristics of a light wave remain constant? Okay, frequency has to be one of them, so 4 is out. The speed changes, the wavelength changes. Frequency and period, because they are literally linked to each other, frequency is 1 over the period. So if frequency changes, period has to change. Alright, number 24. Speed of a light ray in corn oil. Alright, corn oil. That seems oddly specific. Let's find corn oil on my reference table. Corn oil has an index of refraction of 1.47, and I know that the equation is N equals C divided by V. So 1.47 equals 3 times 10 to the 8th. Oops, just kidding. 3 times 10 to the 8th divided by V, which means I need to multiply both sides by V, divide both sides by 1.47. So 3 divided by 1.47 is about 2.04 times 10 to the 8th meters per second. Alright, spreading out of a wave after passing through an opening. That is diffraction. That is textbook diffraction. Remember the picture on the front page of your little green book is the little barrier and the wave spreading out afterwards. So frequency is this, and period. Oh, well, I just told you about this. So 1 divided by 5 times 10 to the 10th is going to be 2 times 10 to the negative 11. After two light waves have interfered, the two waves will be unchanged. They interfere with each other, and they very briefly interact with each other. After they interfere, they just carry on their merry way, and they do nothing else. Glass rod is rubbed with silk. the positive charge is given. Okay, this doesn't make sense, and this doesn't make sense. But also, this doesn't make sense because I can't do anything with protons, so it's positive by removing electrons. Photon with a certain amount of energy has a frequency of, that sounds fake, which means it's in that specific part right here. Energy of a photon is h times the frequency. H is Planck's constant. It's on the very front page of your reference table. So I know the energy is 1.33. I know that Planck's constant is 6.63 times 10 to the negative 34. So a little bit of math tells me 1.33 2.01. So that is choice 2. Alright, speed of a car is increased uniformly from 11 meters per second to 19 meters per second. I want the average speed. Alright, this was something from the worksheets that we did a minute ago. If you need an average, simplest way to do an average is just how many numbers you have, right? Add them all together, divide by how many numbers you have. So 11 plus 19 divided by 2 is 15. The energy equivalent of the rest mass of an electron. I need energy with a relationship to mass. That's E equals mc squared. The mass of an electron is on the front page of your reference table. It's 9.11 10 to the negative 31, I'm pretty sure. Speed of light is 3. So the energy equivalent is going to be right here. 8.2 10 to the negative 14th. Don't forget to square the speed of light, by the way. Alright. Spring has an unstretched length of 0.4 meters. It's stretched to a length of 0.6 meters. When you hang a weight, what's the spring constant? Alright. So I'm looking at spring force is k times x, where x is a stretch length. So I know 10 equals k times 0.2, because we stretch it 0.2. 10 divided by 0.2 is 10 times 5, which is 50. Alright, while this switch is open, this circuit has has 1, 2, 3 things. However, when this switch is open, if you look, I can loop like this. I am unable to finish a loop here. I am unable to finish a loop here. So there's only electric current in lamp 1. Alright, what correctly represents electric field? Kids, one of these things is not like the other. These two tell you the same thing. These two tell you the same thing. It has to be choice 1. Also, it points away from positive and towards negative. Okay, out of phase. This phase thing, right? When you have the phase question, you need to think of the wave kind of like a sine wave, where it's like 0, 90, 180, 270, 360, and it just repeats, right? Or for like, what is it, pi over 2, pi, 3 pi over 2, 2 pi, something like that. But if you look at these points, right, A and B are 90 degrees apart from each other, right? If I was looking at C and D, if I started counting this kind of here instead, if I looked at this as like 0, 90, 180, 270, 360, then like C to D, that's 90 to 270, that's 180, right? A to E is way too much. B to C is 360, that's way too much. C to D is way too much. It's D to E. That's the spot where I'm at. It's from D to E. That's a 90 degrees out of phase. Think of it like a sine curve, like a sine graph in your math class. More multiple choice. We love multiple choice questions. All right. Height of an individual step on a staircase. Okay, 10 to the 0 is 1 meter. So this is a 2 meter staircase. No, it can't be bigger than that either. All right. 10 to the negative 2, this is a centimeter. It's like your fingernail. So that's also a pass. It has to be this one. It's just a weird, you have to try to recognize what's what. Almost always, the big ones are not going to work for something small, right? The staircase. 1 step on a staircase. it's going to be about 0.2 meters, which is choice 2. Okay, what is the magnitude of electrostatic force on an electron by another electron when they're this far apart? Specific equation. So this guy here, it's Coulomb's law, but I need the charge of an electron, charge of another electron, the distance apart. All right, fortunately for me, the charge of an electron is on the front page. It's 1.6, 10 negative 19, so I can do some math. Also, the electrostatic constant Q, or K, sorry, is also on there. So 1.6 times 5.1 squared times 8.99, which is going to be 2.3. Oh, I need an exponent. Negative 19, negative 19, negative 19, negative 19 is negative 38. Negative 36. And then 9 is 27. Pretty sure it's 26. Should be choice 3. Not using an actual calculator, I'm using my phone, which is unfortunate. But I'm pretty confident about that. Negative 38, negative 36. 0.99 times 9. Yeah, that should be right. That should be right. We should be fine. Pretty good about that. Feel pretty good about that. Alright. Moving on. After a 65 Newton weight has fallen a distance of 5.3 meters, the kinetic energy is... Okay, long way, short way. Long way would be kinetic energy is 1/2 mv squared. Try to find the v. Use this to find mass. Short way is that work is the change in energy. And work is force times distance, which I have, which is 65 times 5.3, which should be 340 joules. 0.5 kilogram cart traveling to the right collides head-on with something traveling to the left. What's the total momentum? Alright, I gotta do the momentum of object 1, momentum of object 2, and because they're going different directions, I need to subtract them. So half of 2.2 is 1.1, 0.8 of 1.1 is 0.88, 1.1 minus 0.88 is 0.22. An object weighs 2 newtons pushed across a horizontal frictionless surface by a horizontal force. What is the net force acting on the object? If there's no friction, and this is the weight, which means it's cancelled out by the normal force, then the force acting on the object is 4 newtons, because it's just whatever you're pushing with. Alright, ratio of AM to FM. So I'm looking at wavelength. Okay, wavelength of AM, wavelength of FM. Alright, so AM is here, 10 squared. FM is here, kind of 10 to the first, or 10 to the third and 10 to the first, right? So it's 2 to 1. Wait, no, that's bad math. 10 to the third to 10 to the first. That's 100 to 1. That's choice 3, sorry. That was bad math. Oh, counting is hard. Ratio means set it up like, yeah, y'all have done ratios, like 3 to 2, something like that. So when you have to do it for this, it's like 10 to the third to 10 to the 1. Well, that's like saying 10 squared to 1. So I'll leave that up, actually. 10 to the third to 10 to the 1. It's 1,000 to 10, which is the same as 100 to 1, which is a 10 to the 10 squared to 1. Charm quark. Sounds fake. Charm is plus 2/3 of the elementary charge, which is 2/3 of 1.6. So 2/3 of 1.6 is about 1.07. Alright, here's a diagram. What are the readings? Okay, so how many volts are being used? Well, it's 12, but that has to be Y. So Y has to be 12, so these are off the table. X is measuring the current. Current is V divided by R, which in this case is 4. So V equals I times R. 12 equals I times 3. So I has to equal 4. Right? So X has to read 4 amps. Y, which has to read 12 volts. Alright, toy airplane. 10 circles, 30 seconds. What's the speed of the plane? Now this is tricky because the radius is 4 meters, but that's not what the plane is traveling. The plane is traveling the circumference of the circle. Circumference of the circle, circumference is pi times d, or 2 pi r, which for reference just is on your table. Circumference is 2 pi r. So 2 times r is 8, times pi is 8 pi. So 8 pi is 1 circle, but they do 10 circles, so 80 pi. So the distance that's traveled is 80 pi. Takes 30 seconds to do it, which is 8 pi over 3, which is a little more than 8. That's going to be choice 4. Alright, falling freely from rest. It is not the same amount of distance. Oh, hello. And the velocity goes up constantly, so it's choice 2. It's not like this. These aren't good because the displacement doesn't go up constantly. It goes up, it's curvy. Ooh. Hello? Get out of here. Thank you. Sorry about that. But this is going to go up like this, right? And then the velocity doesn't go up like that. It goes up constantly. What happens to the kinetic energy and the height above its release point? So as it goes upwards, it slows down. Only one of these shows slowing down. Only one of them shows less. Alright, particles in a spring. Longitudinal wave. That's the one that goes along the spring, which means it's going to be choice 2. This was a little pulse that I made while we stretched out the spring. What do you get when x and y overlap? If it's 0.3 and 0.3, then they'll add up to 0.6. Sound wave of constant frequency. It approaches, passes, and moves away from an observer. It's a higher frequency at first, a lower frequency later, and it's sudden. Well, Meow. I don't like this graph. I really dislike this graph, actually. I think it's choice 2. What graph best represents the frequency detected by the observer, approaches, passes, and moves away? It should be high when it comes towards you. It should be lower when it goes away from you. Ooh. Ooh. Oh. Oh. My gut says this, because it should be a higher frequency until it gets to you, and then it's a lower frequency, because it's giving off a wave of a constant frequency. 90% certainty. It's choice 3. I'll come back to it if I have to, but 90% certainty is choice 3. Anyway, last one here. Combination of two identical resistors connected in series, equivalent resistance of 10, which means it has to be 5 plus 5, because they have to be identical, and that's series. But if I do it in parallel, that means I have to do 1 over 5 plus 1 over 5 equals 1 over the resistance. So that's 2 over... That means that 2 over 5 equals 1 over the resistance. So the resistance is 5 over 2, which is 2.5. Alright, that's a multiple choice section. Short answer section. Yep. So this was one that actually needs a protractor and ruler. And the reason you need a protractor and ruler is to figure out what the scale here is, right? So you'd actually measure this. Determine the linear scale. You'd measure this. Measure the length of B. That equals 20. Right? And so you can make it so that if it was a 5 centimeter line, then 5 centimeters equals 20 newtons, or 1 centimeter is 4 newtons, right? That would be your scale. Right? On the diagram in your answer booklet, use a protractor and a ruler to construct the resultant. Right, this resultant, if this is also B, then my resultant is going to look like this. Here's R. Right, and there it is. And then determine the magnitude of the resultant force. In order to do that, you could try to do some kind of like law of sines nonsense, but also you have a scale. Measure how long R is. I don't remember exactly how long this is, but if you measure the length of it, multiply by 4 newtons, because that's your scale, you get your answer. Right? If they ask you to do something like that, chances are, if they ask you to find a scale, make a scale, you're going to use the scale later. Alright. 54-55 is a show all work. So, pushing the box, right? So I have a force and I have a distance. So work is force times distance. It's 25 newtons times 6 meters, which is 150 joules. I'm pretty sure. Is that how math works? 3 times 50? Yeah. What happens to the total work if the coefficient was increased? Alright. If there was more friction, then I would need to use more force, which means the total work done would be more, or it would go up, or it would increase, any of those, right? And any version of that. Alright. On the diagram in the answer booklet, find the reflected light ray. Okay, so this is the surface. So you'd have to do this, and you have to make sure that these angles are the same. And that's the big deal. 58-59, show will work. Determine the amount of charge travels through wire in 36 seconds. So current is Q divided by T, which means that 5 amps is Q over 36 seconds, which means that Q is, what's 5 times 36? 5 times 30 is 150, 5 times 6 is 30, it's 180 coulombs. There it is. Alright. Spring with a spring constant has 2 joules of elastic energy. What is the change in length? Okay. 1/2 kx squared equals the potential energy of a spring. So that means that 2 joules equals 1/2 times 100 newtons over a meter times x squared. So now 2 times 2 is 4, divided by 100 is 0.04. 0.04 meters squared equals x squared, which means that x equals 0.2 meters. Monochromatic light ray. What's the index of refraction? Okay. from air into medium X. So N1 sine theta 1 equals N2 sine theta 2. N1 is air. That's just 1 times the sine of 45. That's going to equal N2 times the sine of 29. And then math tells me, alright, I need to actually do some sine 45 divided by sine 29 is 1.46. There's no units on that because the index of refraction is just a number. Alright, and then the energy of a photon of this light. Well, energy equals h times f, or energy equals, if we look, also h times c over lambda. So h times c over lambda. So that means that it is 6.63 times 10 to the negative 34th joule, oh god, joule seconds. What are the units for Planck's constant? Let's look before I make it up. Yeah, joule times seconds. Nailed it. Joule times seconds times the speed of light, which is 3 times 10 to the 8th meters per second, and this wavelength is 488 times 10 to the negative 9th meters, because they are nanometers, and I need to convert to meters. Nano is 10 to the negative 9th. That's the tricky part here. If you do the math, let's do the math. Let's get my calculator out. 6.63 times 3 divided by 48. Negative 34 plus 9 is 25. Plus 8, or negative 25 plus 8 is negative 17. Pretty sure this is 4.1 10 to the negative 19 joules. My exponent might be off, but I don't think it is. Ooh, hello. There. Sorry. Double checking my answer key. Yeah, 4.1 to negative 19. They said 4.08. 4.1's fine. All right. We move on. Part C, nearing the end. 66, 67. It's a two-part question. Again, show all your work, blah, blah, blah. Okay, so, cross-sectional area. Alright, it works at 20 degrees Celsius, and it works, and that is important because if we look at the coefficient, or the resistivities, they only work at 20 degrees Celsius. So tungsten is 5.6 10 negative 8. So the resistance of a wire equals rho times L over A. The resistance is 19. That equals 5.6 times 10 to the, I already forgot what the number is, negative 8 ohms per meter, or ohm meters. Times 0.22 meters over whatever the area is. And, yeah, okay. So, a little algebra tells me that the area is about, hold up, it's about 6.5, 10 to the negative 10th. squared. Why does the resistance increase when the bulb is being operated compared to 20 degrees Celsius? Because the temperature increases. As you use the light bulb, it gets hotter. The hotter it is, the more resistant that material gets. Which is why your phone tends to slow down when it heats up. Resistance gets higher. And then calculate the power of the light bulb when it's operated at the 120 volts. Okay. The power is V squared divided by R. And I have both of those because I have 120 volts squared divided by 240 ohms, which is, I'm going to try to do that math in my head, 120 times 120 divided by 240. That is a 60 watt light bulb. Power in watts. Alright. 7172, horizontal component. That means I'm looking for this side of the triangle, which is cosine. So cosine 30 equals x over 150 newtons. I should be thorough. Cosine of an angle is adjacent over hypotenuse. There's an equation here, substitution, and then the answer is just going to be 150 times the cosine of 30, which is about 129.9. I'm going to call that 130 newtons. What is the frictional force? 130 newtons, and I know that because constant velocity. So if I know the force going this way, then I also know the force going the other way, equilibrium. And then calculate the normal force. Alright, well, force of friction equals mu times the normal force. So I have that 130 newtons equals wood on wood. So I need the kinetic coefficient for wood on wood, which is 0.3. 130 equals 0.3 times the normal force, which means that my normal force equals, do 130 divided by 0.3, it's 433 newtons. You can call it 433.3, just be reasonable with your rounding, you know. Alright, flat level road, 1500 kilogram car, radius of 45 meters. This is the acceleration. What's the speed? Okay. Acceleration is v squared over r. Right, so that means that 3.2 equals v squared. Oh, I'm gonna get a point off. I'm gonna try to not get a point off. Let me put it that way. Clear erase, please. There we go. 3.2 meters per second squared equals v squared over 45 meters. I'm working my way this way this time. So v squared, I'm just going to skip straight to the end. 3.2 times 45, square root of that is 12. So v equals 12 meters per second. Boom, done. What is the centripetal force? Well, that's just, this time I don't need units or anything. 1500 times 3.2 is 4,800. 4,800 newtons. Shush. Not the time. Okay. What provides a centripetal force? Friction. No friction, no centripetal force. What happens to the centripetal force if it slows down? Well, if you slow down going around a curve, you don't have to lean as hard, so it decreases. All right, last set. Label one node and one antinode. Here's a node, here's an antinode. Boom, done. What is the wavelength of this wave? All right, and let me put the antinode here so you can see. So this is not the whole wave, right? It's only half the wave. So the wavelength is actually 1.24 meters, because you see half of the wave shape in 0.62 meters, so I need to double it to find the whole wavelength. What is the speed of the wave on the string? Well, I know that the frequency is this. So velocity is frequency times wavelength. I'm going to scroll down a little bit, which means that it is 196 hertz times 1.24 meters, which is 196 times 1.24, which is 243.04, really just 243. Can we erase it all, please? Can we erase it all, please? Thank you. Meters per second. And then what happens to the frequency when we shorten the vibrating portion by pinching, right? So what happens to the frequency? The frequency increases. It goes up. It makes a higher sound, a higher pitch, and that's what frequency is associated with. All right. That was the 2018 Regents. Went through all of it, right? Oh, that's interesting. Oh, we're still on draw. Okay, get out of here. That'll do. Okay. Overall, not bad. All right, a couple of weird questions, but it's super, super doable. I took like 45 minutes, 40 minutes to go through this or something like that. You have 3 hours. You have 3 times as much time to do this as I just spent here, right? Take your time. Use your reference table. There's so much on here. Tells you what equations to use, tells you what the constants are, gives you an idea of where to go, right? I'd be in the habit... Oh, we're doing it again. I'd be in the habit of listing out the variables like I did at the very beginning. Like, this will help you greatly just to figure out what equation can I use. Because there are only so many ways to go, right? Alright, if y'all still have questions, if you're going through this, if you're going through another test and you're like, I don't really know why the answer is this, please send me an email. Otherwise, get some rest, remember a calculator and a writing utensil, right? Pen and pencil. And I will see y'all on the 23rd. It's coming soon. Take care, kids.